I'm assuming we're going to find the area. Oh, we do. So AC is the diameter of the semicircle, BA and BC equals 6 centimetres. That's all fine. I will do something that I regularly forget to do one of two things with this. Semicircle, so you need to halve your answer, and always remember to use the radius to find an area. Okay, let's start off by finding out what AC is, and that is much more simple if you just put it this way. So hang on, I don't like the way I've just drawn that, but basically this is A, B, C. This is a right angle, this is 6 and 6. So it's a right angled triangle. You don't know the hypotenuse, but we do know 6 squared plus 6 squared equals AC squared. So that's 36 plus 36. We are using Pythagoras, by the way. Equals AC squared. So we know that 72 equals AC squared. So we know that AC equals root 72 because we're rooting both sides. Okay, and I'm just going to put root 72 into my calculator because I think it'll give me the nice third, so it's 6 over 2. So AC equals 6 root 2. Now, we now know, so if we know that, we know that the radius, therefore, equals 3 root 2. And how do we find the area of a circle equals pi r squared? So that means we've got the area of the entire circle would equal 3 root 2 squared times pi. And because it's a semicircle, it's over 2. So that would be 9 times 2, so that's 18 pi over 2. So, sorry, 3 root 2 squared. I'm just going to show you this. It's another one of these little ones. So it would be 9. It would be 9, and then it would be root 2 times root 2, which is 2, so it's 9 times 2. I don't think I needed to use that. Right, so that's 18 squared, and then so that's 18 pi over 2, so that's 9 pi. So we know that the area in here is 9 pi. At one stage I will make everything nice. So the area of ABC, the triangle, is going to be 6, so area of ABC equals 6 times 6 over 2, which equals 36 over 2, which equals 18. So it's 18 plus 9 pi, and then just put that into your calculator and that'll give you the answer. Shift pi equals, so that's 46.2743, but we're only doing it to one decimal place, so it's 46.3. I'm assuming centimetres squared. So that's your answer, 46.3 centimetres squared. Well done. Right. Ooh, this is something that's really peculiar to IGCSE. It's this sort of indices that looks at, usually you're looking at highest common factor and lowest common multiple, but in this case we're doing A equals 2 to the power n times 3 times 5 to the power m. And what they're asking us is, if it's 8a, what do we do to this? Well, 3 you can't do anything to because that doesn't make any difference to 8, so we'll leave 3 like that. 5 isn't anything to do with 8 either, so I can't use anything non-complicated. But I do know that 2 to the power 3 equals 8. So I'm going to change 2 and put a 3 there and leave an n there and times that out. So that here is my answer. Right, C equals minus A, B minus A, sorry. So A is 6, correct to the nearest integer, and b equals 15, correct to the nearest 5. Okay, so before we carry on with anything else, I'm going to do a equals 6. What's the next integer up? 7. What's the next integer down? 5. So that means a could be anywhere between, and then we'll halve the point here, between 6.5 and 5.5. Okay, so our lowest bound for a is 5.5 and our upper bound for a is 6.5. Now b is 15, and that's correct to the nearest 5. So its upper bound would be 20. Its lower bound would be 10. And then let's find the middle point of those. So that's 12.5 and that's 17.5. So now we've got a lower bound and an upper bound. Now, work out the upper bound. So we want C to be as big as possible. So C needs to have its upper bound. And show you're working clearly. Well, so far it's been quite clear. So C equals B, so we need it to be big. So we want B to be the biggest it can be. So the biggest it can be is that. So C equals the upper bound of B, which is 17.5. And in order to get the biggest bit of C that we can, we need to take away the smallest bit of A that we can. So we need to take away the lower bound. So minus 5.5. So that means that C's upper bound is 12. Okay, next. Factorise this completely. Now, we could do this in a couple of different ways, but we're going to do, so 2x squared minus 7x plus 6. I'm going to times 2 times 6, because that will just make life easier. So what we're going to be trying to find is something that times us to 12 and adds to minus 7. So something that times us to 12 and adds to minus 7 would be, I think, minus 4 and minus 3. Because they do both of those things. Okay, so what we're going to do now is we're going to rewrite this again. So we're going to go 2x squared, and we're going to split up the minus 7x into minus 4x and minus 3x plus 6. And we do this when we're looking at expanding brackets anyway, and then we clear it up and make it look like that. So now we're going to split this into 2. So we're going to split it down the middle, and we're going to think, what does 2x squared minus 4x completely factorise to? And it factorises to 2x bracket x minus 2. And what does minus 3x plus 6 factorise to? Well, it would factorise to minus 3, then x minus 2. So that means we know that this is factorised to 2x minus 3 and x minus 2. And we don't need to solve it, so we just leave it there. Put that there. Right, solve, blah, 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 and show clear algebraic working. So we've got 4m plus 9 over 3 equals 7 minus 2m. Now my favourite thing is that I hate having things underneath things. I don't really like denominators. So my inclination is to times both sides by 3 before I have to worry about anything else. So we'll do 4m plus 9 equals, and then you could do that 7 minus 2m. I know it's really tempting to just do it immediately, but good. Right, so 4m plus 9 equals 21 minus 6m. I'm going to add 6m to both sides, and that means that all my m's are going to be on one side and really positive. Okay, so I've got 10m plus 9 equals 21. So that means 10m equals, we're going to take 9 off both sides, equals 12. So m equals 12 over 10, which is 1.2. Or 6 over 5, if you want to solve it that way. It doesn't really matter, both are fine. Okay, right, so the fourth root of y over y in the form y to b, where b is a fraction. So that means you just write out y to the power quarter over y to the power 1 is what that means. Now we know that that's the same as saying y to the quarter minus 1, isn't it? Because you could do this if it was, we could do it when it was e9 over e5. So now y is a quarter minus 1 would be minus 3/4. And that's your answer. I don't know if we just needed to write b as a fraction, but anyway, that will work. So, next. Oh, good. Now this is cool because it's actually a tree diagram that doesn't involve putting sweets back into a bag, which I always find absurd. Okay, in group C, there are 6 girls and 8 boys. Now that means there's 14 altogether. Okay, so we're going to use 14 at the bottom, I presume. And in group D, there are 3 girls and 7 boys, which is always nicer because that's 10. So I'll put 10 at the bottom, 10 at the bottom of that, 10 at the bottom of that, and 10 at the bottom of that. Excuse me, I'm just recovering from a cold. So group C is 6 girls over 14 and 8 boys over 14. And then this is 3, 7, 3, 7. And I presume that's what we were meant to have done. Yeah, complete the tree diagram. Now, what's the question? Work out the probability that there are 2 boys in the team. So that means we go down the one that goes boy, boy. So it's that one. So in order to find out the root of something, we go 8 over 14 times 7 over 10. And that equals 56 over 140. Which will, well, they're both divisible by 7, so I'm assuming that goes to 8 over 20, which goes to 8 over 20 would be 4 over